The next thing we need to do to make this a useful outline is to clean up the intersection of the two roads so that we have one continuous closed spline. Right now we have two overlapping splines. Continue from the previous lesson or open the file roadoutline05.max. Select the shape roadoutline01. This is a compound shape containing two closed splines that we will be editing. The intersection of the two roads needs to be cleaned up by trimming away geometry in the overlapping areas and then welding the extra set of vertices so that it becomes a continuous closed shape. Let's do the trimming first. We need to be working at the spline subobject level. So in the Modify panel, click on the spline subobject. Using your mouse wheel, scroll up to zoom in to the intersection. Now we can see a little better what we're working on. It's a good idea to work close to your subject. This avoids possibly clicking on areas that you don't want to click on. In the Modify panel, navigate down below the Outline option and locate the Trim command. Now click on the Trim button. The first area that we will trim is the short segment of the 60-foot wide road that's inside of the 40-foot road outline. Go ahead and click on the spline in between the two vertical edges of the 40-foot road outline. That will trim that segment out. Then click on the overlapping portion of the 40-foot road. Now this looks like a closed spline with a nice clean intersection, but we actually have two vertices at each intersection point that will make this useless as a closed spline. Now we need to work at the vertex subobject level. In the stack view, click the vertex subobject level. In the viewport, click and drag a window to select all of the vertices at the intersection. If we look in our Modify panel and we scroll the panel up to the selection rollout, we can see that we have 4 vertices selected. What we really want is to only have 2 vertices. That would make it a closed spline. In the Modify panel, scroll until you find the Weld option. Notice we have the Weld button. Now we're not going to click yet, and a numeric value called the Weld threshold value. This is a numeric value that indicates the radius of influence around each vertex in which any selected vertex will be welded. If the radius of each vertex overlap, then those vertices will be welded together into a single vertex. This rule only applies to vertices at the beginning and end of open splines. Since our roads are very large, we can use a value of 1 inch and not worry about all the vertices being welded together. Go ahead and type in 1 inch, then press Enter to accept the value. Currently we have 4 vertices selected. Click the Weld button. Notice the vertices become deselected, and we also notice a change in color of one of the vertices. Drag a window around these 2 vertices. Go ahead and scroll the panel up and find the number of vertices selected. You'll notice now that we only have 2 vertices selected. So welding creates a radius of influence around each vertex based on the size of the threshold value. If 2 or more vertices at the beginning or end of an open spline overlap their radius of influence, they will be welded together. This was important in this case in order to be able to close our spline after editing and trim away the overlapping portions. It's also very important to understand this when you import 2D data from CAD files. Quite often the import process will cause overlapping vertices not to be welded, and you'll have to weld them together manually in order to correct the problem. As before, exit subobject mode. Zoom back out so we can see the entire scene and press Ctrl+S to save the file.